So in problems number 38, 39, and 40, they ask us, and this first number was wrong, it's a 3, it's not a 1. And they asked us, hey, if this is a sequence, what type of sequence is it? Arithmetic or geometric? Well, arithmetic is when you add or subtract each one. So, you say 5, you add 5 or you subtract 5 to each one to get the next one. Now, obviously, I'm not adding to each one to get the next one because it's going up by a larger amount each time. Okay? And then the next type is geometric. Then geometric is multiplying or dividing. Right? And we're not doing that either. So this would be more like a linear function. Right? So this is like x plus some number. It could be a negative number, whatever. And this one would be written as some number times x, which could also be added to some number.
Please excuse this interruption. Good afternoon, everyone, and happy Friday. This is an announcement that starting next week, we are doing a Winter of Kindness campaign to combat bullying.
Winter of
The
Kindness.
first day will be Odd Socks Day.
Odd socks.
Highlight everyone is different. We are all going to wear odd socks.
We're all different.
So, please join me in this campaign. Odd Socks on Monday.
Odd
Winter
socks.
of Kindness campaign. Thank you.
Campaign to you. Alright, ready guys? So, it's not geometric because we're not multiplying to get to the next one. Because I was thinking about going, wait a minute. Can I multiply to get to the next one? And like, no, but what I can do is I could say, hey, this is really close to 5 squared, right? And this is really close to 5 cubed, right? And this is really close to 5. In fact, they're so close that they're 2 away. So it'd be 5 plus 2, or 5 squared plus 2, or 5 cubed plus 2, right? The problem with that is, or 5 to the 0 power plus 2. But the problem with that is this is our first, second, third, and fourth set, right? So, in order for us to set this up correctly, because I think we're finally getting it, that it's 5 to the 0, 5 to the 1, 5 to the 2, 5 to the 3. This is what we call recursive. And this is when we get into summations and productations. We can write this in a recursive formula, right? In a recursive productation formula. It's really easy, okay? We basically say that it's 5 to the x, right? Plus 2. But the problem with that is when 1 goes in, this doesn't become 1, right? If we want it to become 0. So how do we turn a 1 into 0? Well, we subtract 1, right? So in this recursive statement, we would have to say x to the, or 5 to the x minus 1. And so now each statement is its own set. To get to its own set, I would put in the next number. So that's how I would get to each number, depending on which one it is. So if I wanted to get to figure out, it asked us, could you figure out the term for the 16th term, right? So for u of 16, and I could take f of 16 is equal to 5 to the 16 minus 1 plus 2. And then I basically just take 5 to the 15th power. So 5 to the 15th power equals a really, really big number, and add 2 to it, plus 2 equals. And on the calculator, it's so large that it's hard to see. So it's 3.051757813 times 10 to the 10th. So it's really 10 decimal places over. It's so large. So I kind of went a little crazy on this one, throwing a recursive ball at you. And then it said, hey, could you find one for an n value? And well, yeah, that would be simply said f of n would equal 5 to the n minus 1 plus 2. And so now I have a formula to figure out any value I wanted. I have a formula to figure out the 16th value that I wanted, all stemming from the pattern. So we had to be able to figure out the pattern first. We're going to do this again, but with something like, what if I did it with 1, 3, 5, 7, right? Then we would know that each one would be adding 2, right? So I would say x plus 2. Well, does that equal 1? When I plug in a 1 here, is what's 1 plus 2? And 1 plus 2 is not 1, is it? So to get to 1, I have to think, what plus 1 plus 2? Because each one of these is a plus 2 function, right? So this is what we would call an arithmetic function, right? So I'm adding 2 to each one. But what could I add to the 1, 2, 3, 4th? So to the first one, what do I add to 1? What do I do to this x in order to make it so that when I add 2 to it, it becomes 1? And so what I would do is I'd say, well, 2 plus negative 1, right? So what if I made it negative? Would that work? And I don't think it would. So multiplying it by a negative is not going to make it work. But what will work is if I subtracted 2 from this value and then added 2 to it. So if I took 1, what is 1 minus 2? Is negative 1, right? And then what's negative 1 plus 2? Well, that's 1, right? Okay, then, but what about 2? What is 2 minus 2? Okay, so 0 plus 2. 2, that's not 3. And then what about the 5? How can I make a 5 out of it? So out of a 3. So if I had a 3 minus 2, that would be 1, right? And what's 1 plus 2? 3. So now I'm getting my 3, but I lost it going from 1 to 3, right? So I gotta fix it going from 1 to the 3. What am I doing wrong here? Yeah. What am I doing wrong here? What if I did 2? Still wouldn't work. If I did a negative 1, then it'd always be negative.
Wait, what are you trying to do to find 5?
I'm trying to get so that I can add a number to make it a 3, to make it a 5, to make it a 7.
I mean,
Right? Now if I started it off with just the 3, I think the 1's throwing us off. So if I started at 3 and went from 3, 5, 7, right? And this was 1, 2, and 3. And I plugged in 1. 1 plus 2 is 3, right?
Yeah.
but what's 2 plus 2? It's not 5, is it?
No.
Right? So what's going on? Why is it messing with me? And I just figured it out. So why is it messing with me?
Can you start with a -1 or no?
I think what was happening here is it's not really starting with the -1 that's messing with me. I think what I realized is I have to have it times something. Right? I have to say, like, what's 3 times x? So what's 3 times 1?
3.
Right? So 3 times 1 would be 3, right?
Yeah.
And 3 times 1 is 3. And then if I subtract 2 from it,
Then add 3.
what would it be? If I
Oh,
subtracted
no,
2
never mind.
from
Oh,
3
yeah.
would be 1, right?
Yeah.
Okay? So then what if I said 3 times 2?
6.
And that would be 6, and 6 minus 2,
4.
that'd be 4, not... What is going on here? Why is it not working? I'm confused.
Wait, it's class out?
Yeah. Oh, why is this not working here? It's actually going on. Something multiplied against 1. There's got to be a 2. We're adding a 2 to an x. If we plug in 1, 1 plus 2 is... Oh, that's it. Duh. So if I add... We're adding 2 every single time, right? So I have to have 2 times the x, right? 2 times 1 is what?
2.
2, right? So how did I get back to 1?
Subtract, yeah.
Right? And then 2 times 2 is what?
4.
Minus 1.
Oh, okay, and then you
You
add
see what I'm saying? And then
Yeah.
3. 2 times 3 is what?
6.
And then minus 1. Now I'm getting it back. So I had to take this number, right? And use it as a multiplier,
Yeah.
right? Because that's how many times I'm adding it. Does that make sense? Alright, so now we've got it. This is our arithmetic formula, right? And so if I wanted to find out f of 16, then I just plug it in. 2 times 16 minus 1, and 2 times 16 is 32. Minus 1 would be 31. So f of 16 in this case would be 31. So if I have you find an arithmetic formula, that's how we would go about doing it. And if I wanted to do it in forms of n, then it's f of n is equal to 2 times n minus 1, right? So that's our formula. And so that's for recursive. This is for arithmetic. And I'll let you figure out the the geometric one, which will be a power. So if we're multiplying each time, right, then it's going to become a power, right? So, so our x is now becoming a, instead of 2 to the x, it's going to be like 5 to the x, right?
Lenora Baker, please report to the middle school office. Lenora Baker, please report to the middle school
So
office.
this is our geometric 5 to the x power. So that's how we would get it. We'd have to multiply each one to get to the next one. Geometric. Okay, we'll see you tomorrow.